Problem number 11 says evaluate the limit. So it gives us a limit as x approaches 1 from the right, so remember the plus means from the right, a minus sign would mean from the left, of tangent pi x over 2 times ln of x. So the first thing I do whenever I see a limit problem, always evaluate it at that point and see if it's indeterminate. Because if it's indeterminate, you have an option to do L'Hopital's rule to reduce it down. But sometimes you might surprise yourself and it might actually evaluate to a non-indeterminate form, which would just be the final answer. So in this case, if I plug in 1, I end up getting tangent of pi over 2 times natural log of 1. Well, natural log of 1 is 0. Tangent of pi over 2, if I look at the graph of tangent pi over 2, it looks like this. It's asymptotic right when it hits pi over 2. It goes to infinity. So I end up getting infinity times 0. Infinity times 0 is an indeterminate form. So this limit is indeterminate, but it's not in a form that I can use to L'Hopital's rule to evaluate it. It has to be in a fractional form. So if I look back at the original limit, tangent of pi x over 2, ln of x, I go back and evaluate it, I look at this original limit, I need to get it into a fractional form to be able to apply L'Hopital's rule. So what I can do with the tangent, I don't really want to mess with this. I can do something with the tangent though. And tangent has forms that you can use to bring it down and bring it above by changing its overall form. So remember, tangent of x is equal to 1 over cotangent of x. And vice versa. Cotangent of x is equal to 1 over tangent. So I can rewrite this as 1 over cotangent of x. So if I go through and write that out, I end up with ln of x over cotangent of pi over 2 x. And now, when I go through, I already know it's indeterminate, so changing its form shouldn't change anything. So I can go ahead and just apply L'Hopital's rule to this. So I'm going to write a little L apostrophe H to say that I'm doing L'Hopital's rule, and I derive the top and I derive the bottom independently of one another. Derivative of ln of x is 1 over x. Derivative of cotangent of pi over 2x is equal to pi over 2 times the derivative of cotangent is negative cosecant squared. So this would become a negative cosecant squared pi over 2x. And remember, this pi over 2 comes from the chain rule that you have to apply when you're deriving it. So I would derive the inside and get pi over 2. That's where that term comes from. Okay? Now I'm still evaluating this at the limit as x approaches 1 from the right-hand side. So if I go through and plug in 1, 1 over 1 is just equal to 1. I end up with negative pi over 2 cosecant squared of pi over 2. Sine pi over 2 is just 1. So 1 over cosecant, 1 over cosecant squared of pi over 2 is just equal to 1 as well. And that kind of deals with the same sort of rule that sine of x is equal to 1 over cosecant of x. So if this is equal to 1, cosecant, it has to also be equal to 1 as well. So this whole term on the bottom just equals 1. Times that negative pi over 2 then. So I end up with 1 over negative pi over 2. And if I look at my answers, D looks like the closest one because it's negative 2 over pi. Remember, if I'm dividing by a fraction, I can multiply by its reciprocal. So this ends up becoming negative 2 over pi when I flip this term. Negative 2 over pi is the final answer. Letter D is correct for number 11.
The Teaching Center, UF's Learning Resource Center.